Try to sound like the announcer. Okay. We are going to reassemble this this last set of planetary gears that I have, and I'm going to try and make it to where I can see the comments as they come along. So give me one moment to try and find it. Okay, so if there's any comments, I'll be able to watch. I'll try to answer. So we have been. Let me get these out of the way. They were supposed to look cool, in the beginning. We have been waiting for Metal Gears. We're still waiting for Metal Gears, but we've been trying different tolerances of PL or not PLA, but the nylon 6. So we've been doing the straight off the plate, cooling it quickly, letting it cool halfway, letting it cool all the way down to below room temperature. And it seems to be that no matter what I do with the nylon 6, it's a strong material. It really is, because the ring gear has survived. It's only taken minimal damage, so it'll survive another run. And that's what I have these other gears for, because we're going to pop these out and we're going to get things rolling on that. I'm just kind of waiting for people to kind of roll in here. I don't know who will. I honestly don't know if people will show up for this. But basically, we're going to be replacing. You can see what happens to the sun gear, which is why I'm having these done in metal. I'm going to go ahead and pop these off. You can see that there's some damage to the planetaries that take place, but it seems to be only at a specific RPM range on that motor. So once it hits that range, it starts to scream a little bit if the gears last long enough, and then it strips them out. So it's a lot of torque that we're dealing with. So what we're doing right now is we're just going to take these out. I'm going to put the new gears on the new bearings, and we're kind of going to go from there. We'll go from there and get everything set up for this new spin up, and then I'll basically be doing it right here with you. There it goes. So it pops out. You kind of snap in there. And at this point, now I know I have a use for my sockets. So now we're going to kind of pop the old bearing, or the old gear, off of the bearing shaft. So there's the old gear. We already know about the sun gear. And now we have our bearing assembly for the next gear. So we'll set that right there. I'm going to pull this off of here. Get this one freed up. And I think we'll go with the paste again, because I think the paste is a little bit thicker. I think it'll give it a little bit more to work with. I don't know. What do you think? Do you think that the Hi Edgar, welcome. If there's a delay in the chat, forgive me, I will answer you. What do you think on these nylon gears? Are the Super Fin, or the Fin Super, or the paste? What do you think we should do on this next run? I've done them both before, and I feel like the Fin Super kind of gave it a little bit more, was less viscous than this, which I don't think played a part in that. But this one, the H2 or HT1200 is heat resistant, so apparently. So we're gonna give it another shot, I guess, on the paste, and we'll go from there. Hello, Hayden. Welcome. Glad you're all here. Right now, what we're doing is just getting these old planetary gears off so that we can pop on the new ones. Okay. So now we have our old planetary gear system. And these basically are getting printed in metal. So I'm starting off with the aircraft grade aluminum. If I tear those up, then I have to go to tool steel. But these here, and I'll put those aside because they're old. And this ring gear is getting done in the aircraft grade aluminum. The ring gear fares fairly well. It's usually the sun gear, obviously, that goes first because it's the one taking most of the torque. Then the planetaries follow soon after. Really soon after. So what we're going to do at this point is, since I've kind of made this all interchangeable, I'm going to tap, I don't know if you can see it, but I'm going to try and do it to where you can see it without destroying it. Okay. Try and get it at the right height here. And it's usually when that screw bottoms out onto the table. Then I know it's good. Okay, so there's one. Get the second one going. And I've been reusing parts like crazy because it's just expensive to order stuff. Not too expensive for the bearings, but... And then having to wait, so... And I have to wait for the... metal gears anyway, which is... That's enough for someone like me. I don't want to wait for any more stuff. I wanted to be here already. Come on. This one's being a little difficult. That's okay though. Sometimes they go right in, and sometimes take a little persuasion. Giggity. You can hear that bottom out on the table. I'm sorry if that's loud on the speaker. I don't know if it is or not. Okay, one more. Come on. Okay, so those new gears are now on the bearings. And now what we're going to do is we're going to snap them into place. Planetary or sun gear upside down. And we'll line these up. They don't necessarily have to line up perfectly because I'm going to have to kind of jimmy them into place. They are notched, so they only go on one way. I will line them up. I'm sorry if my big fat hands are in the way. And there we go. Now we're going to verify that we got Spinny McSpinnerton. It's Spinny McSpinnertoning. I just made up a whole new language there. It looks actually a bit more stable, a bit more aligned than some of the other ones. Again, I've been reusing the same parts over and over and over again just to save some money. But all right, so what we're going to do now, this is the fun part. So this goes into there, over the shaft. If anyone's ever seen me spin this up before, which I'm sure you have because I've been on it forever, this is basically going to be a 4-to-1 gear ratio to this fan. So that's what we're doing next. So I'm going to move the camera up to where you can see where I'm going to, how I'm going to install the gears. Then we're going to hook up the batteries, get the remote, and we're going to try to run it in a little bit, and we'll use the Interflon paste. So let me get you up here. All right. Okay. So now what we have to do is find the section that's worn the most. Actually, it only goes on one direction. So if these are facing the same direction as the gears, then we're in the right, we're in the ballpark. But this part's what irritates me sometimes. Oh, that's why. See, watch. See how now it'll click in there because I almost got it the right way. This is like feel like a monkey trying to wire a circuit board here with a banana. So we get it lined up. There we go. Okay. Now we got some. And we're gonna kind of rotate it until we find that sweet spot where, you know, the whole thing closes. And now we are going to hopefully get this in there in one shot. There we go. And then I'll slide straight down. I'll index it with the fan as soon as I know that it's grabbing the fan. Okay, it is. Pop it in there. I like to give that sun gear a tap so it's over the shaft and it's not, you know, binding too much. That kind of feels okay. All right. Okay. Now, keeper ring, we can't forget that. Get on there. All right. So this is where things start to, where we start to wear things in. So what we want to ensure is that we're not getting too much pressure from the fan, the shaft coming from the fan into the sun gear. Because what that'll do is it'll bind, because they're V-shaped T-screws, it'll bind the sun gear up against the planetaries and make it hard to turn. And it feels like it's a little bit tight. So I'm gonna tap on it a little bit. Yeah, it definitely feels better. But we're gonna have to run it in to make absolutely certain. So what we're gonna do first is let's do the paste. And I'll use this screwdriver to kind of just get some in there. My lives usually go this way. When I get a better camera, it'll be a different story, but at this point, that's the way it goes. And not very many people are interested in this kind of stuff. I'm not sure why. Not entirely certain why, but they're not. So I'm going to try and get as much of this as I can in there to make sure that that sun gear is protected by any friction. Okay, that's enough. Now what we're going to do is push it. I have an index here. This, you can tell I've been using this for a while because I've broken it a couple of times. But what I do is I push it in until this indexes the center of that indexed carrier. And it also grabs it from the outside. And it's run by a 6374 190 kV e-board motor. So it's for like a skateboard motor. I needed something with torque, but I also needed something with RPMs. So let's get this thing lined up here. And let me get my light out because what's going to happen is I've got to make sure it engages it correctly. Oh, it's right here. And so I'm going to turn it until I'm close. This is right about there. All right. We're going to tap that because it just feels, it'll start to loosen up. I know you're like, it looks kind of rough, man. But eventually this is going to be driven from the rear behind the fan, and that's why I designed this fan here. These will all be printed in, this shaft will be printed in metal because the nylon sticks kind of snapped a little bit, but that's kind of my fault for dropping it. And then it'll index here to, if I can get the snap on there, okay. Index over like that, screws in the middle, and that'll turn the fan, and that'll be attached to this, unless I come up with something different. But other than that, it's going to be driven from the rear using the same processes that I'm using here, except this will be attached to the back side of the fan blade case, and this and the bearing case that sits here that holds the fan itself, and that has a bolt pattern on the back. But I'm basically going to make some stator vanes to smooth out the flow depending on the direction that I'm turning it. There you go. And at this point is when, yeah, okay, and like I was saying, basically I'm going to mount it on the back, put some stator vanes in it so that it actually rectifies the flow, and then this entire system will be internal, but it's easier to do all the experimentation on the front of the motor. So having two solutions, having the rear drive fan blade already made and the front drive system already made, kind of gives me the opportunity to work on the outside of the duct work, because all I have to do is unbolt this on both sides and take duct work off, switch everything over after I reprint the mount that holds the gearbox to fit that side with the stators, and then that'll be a more CG balanced motor, because the motor itself will be back behind the blade, and it'll help with cooling. So if you'll give me a second, I have to plug in a hot glue gun, because what we're going to do is we're going to use the hot glue after I get this kind of lined up and it feels good, to kind of hold everything in place just for the test. So we're going to check this angle. There we go. And the top angle. Okay. Pump loose. No, I do not. Well, I do have a body in design, and that's what the MPCNC back behind all this is for, that machine you see in the background. That is for cutting the actual molds that I'm going to be using to do the fiberglass body. I thought about using Bamboo Studios software, which will allow you to take apart and turn it into a mold. So then I would slice up the body of the plane on each plate, make it print as a mold, put them all together, sand them, do all that other stuff. So there's a few ways I can do it. And MPCNC I had built a long time ago, so I figured I might as well get it working again and use it, because it's it needed some work. I did a video earlier where I actually had it working, so and it still does. I just have to do some programming, because I needed to handle that foam board that they use for casting, or for not for casting, but for carbon fiber molding. All right, so they're going to be that, or I'm going to use it with its fourth rotating axis and maybe try to make my own gears instead of having them 3D printed, because I don't have a 3D printer to do it with. But a body is in design. I'm probably going to go initially with an F-35 style, just because it gives you, it's a fairly simple design, but it's really designed for speed and maneuverability. And if this pushes the air that's projected, which it which will only be with the metal gears, because I'm telling you, I hit an RPM band on this, and you're gonna hear what happens. It's gonna get to a certain RPM band, and then it's gonna finish that sun gear off. I've done this a million times. I'm doing it now because I'm waiting for the metal gears. So, this engine's projected thrust output is 55 pounds. So, the drone that I have designed for 4 of these has a lift capacity of about 220 pounds minus the weight of the actual craft, which would probably be around 30 pounds. So a pretty good usable lift capacity, over 150. So that's really the whole idea behind this, a modular engine that you can put in a jet, you can put in a large scale jet, you can make it a drone. You can do anything with it, anything you want to with it, as long as you have a model big enough. I mean, this could even be put into fairly small models, you know, and just do some serious, you know, drag racing. But like I said, we're gonna run this. The nylon gears are going to fail. I already know that, because the hardest material I've used so far is the nylon 6. And while it did go higher in RPM range than you know, PETG carbon fiber and PETG or PLA, they still fail because there's so much force on that sun gear at 4:1, and we're pushing a lot of mass. It's like 0.665 kilograms of airflow per second. So we have a lot of resistance on the blade. So that resistance transfers to the sun gear and then just destroys it. Chad, he has arrived. A few and ultralight. Yeah, you need to go. It would work. I mean, with the projected thrust, you're looking at, you know, I mean, you can put like these all over the place. I mean, they're fairly small for what they are. So once this is all internal, this whole system becomes yay big and only about 190, 200 millimeters with the cowling if you're actually using this ductwork and you're not setting the main fan into a plane. Because without it, without this ductwork, you have this. This is basically like a fan casing right here, without the front part of the fan casing. It would sit back here. Trying to get on this side. So this would sit inside of a plane body and then push the air through, because the fan will be right here, intake, so on and so forth. Motor's back here. Never mind, this was for a high pressure impeller turbine, or not impeller turbine, impeller blade. That I know this looks like a soft serve. I was running out of PLA, so I used some of the wipes. So what I did was I designed an impeller to go in here so that I would get high pressure air through here and through the impeller. It would both be spun by the same motor, but it would feed an afterburner. So again, all 3D experimentation, you know, 3D printing experimentation. So the bearings that this runs on is one of these that the fan runs on. You saw it on the back of this other fan. 6340, I think. Oh, yeah, it's a 6204 RS. So that's what we're using. Sorry, I get numbers mixed up sometimes. So I'm gonna go get the glue gun. Is it just me, or do glue guns never have long enough cords? Okay, that feels, I mean, it's a little tight, but I think it'll be all right. So we're just gonna put some, I just drop some in there and we wait for a minute. And what this does is kind of, it's like tack welding for plastic, you know? Because I've run these parts so many different times, I've broken pieces off. I try to use the parts as much as I can before I reprint or replace. to do the testing. But trust me, for the metal gears, when I do the metal gears, everything's going to be brand new. And I'm going to be doing it mainly out of carbon fiber PETG. For most of it, just for strength, the case and everything else. Now the fan is just straight translucent PETG. That's it. So the fan, we're pushing the limit. If I can get 55 pounds of thrust out of this fan, then we're golden. But we're going to see what happens. That feels a little bit tighter than I would like. That's an alignment issue. But again, we're just burning up the rest of my nylon gears. See what happens. So let's go ahead and get things set up. So you saw how that all went together. It was a fairly simple system. And I think that will be crucial when it comes to maintenance. So you have this cowling, if you're using a cowling for a drone. You can take half of it off. You can get to the gearbox. You can change gears. You can oil gears, grease gears, however you're going to do it. That one ring you saw me put on is going to be, it's going to have a rubberized cap over it that I do, so that I can grease the gearbox, and it'll be kind of a sealed system. And I think that will help with the heat dissipation and the lubrication of the gears when I get the metal gears in. So yeah, I'm going to start it up. Loyal egg, welcome. Yeah, I'm going to start it up. But like I said, as we've seen before on these fans and some of my other stuff, get that hooked up. The end result of the sun gear in a 4-to-1 gear ratio is usually this. So I'm not going to get to half. I may get to half throttle if I'm lucky. When the metal gears get here, we're going to do another live because it'll take it all the way home. So that's what's going to happen. So we're going to do this right now. We've got everything set. Double check. Radio, battery, battery. This is 48 volts. Batteries are sitting at 47.51 volts, so I haven't used very much. This will give you your amp readout and everything else right here. So you got watts, amps, volts per minute, watts per minute, so on and so forth. So let's give it a little bit of a slow, low break-in and see how she does. This is how we'll kind of run it in to see how, to make sure that there's not too many vibrations, and it kind of helps to break the gear in. Oh, did I mention I've got the P-51 back there hanging, just so you can see the airflow? I may destroy that plane, I don't know. All right, so I don't like the way this ESC is set. I got to figure out how to program it. All right, we're going to send it. This is going to be quick. You're going to lose that sun gear. That's what's going to happen. So we'll see how much we get out of it. Are y'all ready? Is everybody ready? Give a thumbs up, share, like, subscribe. Go to my page and check out everything else. All right, here we go. I knew it was going to happen at half. I knew it was going to happen at half. Ah! Every single time. And the end result is always going to be that sun gear right there. You saw the teeth, right? He still wants to try and grab a little bit. Let's let it roll up slow. Will it keep going? Probably not. But to kind of give you an idea of the of how much how I know we got the thumbs up and the dang it. I knew it was gonna go. That's the thing. I knew it was gonna go. But when the metal gears get here and we spin that up, you heard it get to that point where it's ready to scream. It hits an RPM band that this motor changes its RPMs kind of abruptly. And that's what ends up happening. And that may be the settings inside the ESC. I still have to figure out how to program the thing because it's, you know, they've translated it. So it's like, wait for this beep and this many beeps and that many beeps. I may just have to get their programming card and make it easier on myself. The propeller are not stable. There's a propeller. Well, that's my problem right there. There's a propeller, Chad. That's a high-pass fan. Just to clarify, that is a 22-blade high-pass fan modeled after a Boeing engine. Yeah, basically, that's what it is. But this engine's got some torque. That's why I went with a skateboard motor and a 4-to-1 gear ratio. So you can see. So it wants to keep grabbing, but it won't. But that was the idea behind the live. I knew I was going to lose the gears, but I wanted to show it to everybody live so you can see what I do, how I put it together, how I take it apart. And at this point, I mean, there's no heat on the motor. It didn't run long enough. And it doesn't pull very many amps. Even, I mean, I think when I got to about half throttle, it may have gotten to close to 80 amps. But I still had a lot more throttle to go. So I got close to half, but that was about it. And it's usually in that RPM range where I lose it. But that's okay. Because when those gears get here, we got a lot more testing to do. And that's the motor I'm using right there. That's a powerful motor. And if you look at it from the back here, it has plenty of room for mounting back here. I wish this would focus. And then you can see how the motor will sit there, and then I'll have stators that kind of support it. And that'll help the airflow from the front of the engine back this way. Well, it'll also help with the cooling as well. So that's going to be crucial. We also have this thing still working on. This is running on a 90 millimeter EDF. And this particular design looks horrendous, but it has a purpose. And there was a lot of people that didn't like it. So I gave it a GRU nose. Just to go ahead, you know, predator face and a GRU nose. So anyway, it's ballast here and here. And there's going to be like ballast tank tips on the wings. Because this will be able to land and tread water, take off out of the water, has full elevators, so on and so forth. That's what the ductwork is for. Pull water in slowly, tread the water, because it's DC, so it'll be fine. And then when I want to take off, so it doesn't get waterlocked from the front here, from trying to take off, when I elevator up and these dip into the water to push the exit aperture down, then it can pull air in from the top, which will allow it to break free from that kind of suction you get on the water. So everything was done. I even printed my horns and everything in nylon 6, which worked really well. Still waiting for a couple more servos. Got to do the rudder. And it'll have wheels in the front for testing. And I'll have a skid in the rear, actually, to make sure that, you know, it can take off and land on the grass and everything in the dirt where I'm going to be testing it. Because the baseball field where I got to go. So, oh, my radio's giving me issues at this point. It's mad because I haven't moved anything. Let's unplug this. And it's 8-inch fan. So, oh yeah, you're talking about the size of the fan. Yeah, it's a 170 millimeter fan. Yeah, she's The thing is about the way I set this up is you're looking at the 4-to-1 gear ratio setup. All I have to do is back that mount up and add another gear stack, and I've got 16-to-1. If I add the last gear stack, I've got 48-to-1. But I don't have an engine with enough torque unless I get like a 1 kilovolt motor. That's the size of a Buick tire to spin it. But 4-to-1 seems to be the sweet spot. It will give me 32,000 RPMs on the low end, and it'll produce, like I said, 55 pounds of thrust. So again, when those metal gears get here, I will do another live where we go through. You've seen how I put it together, but for those who probably won't have seen it put together, that's gonna be interesting for me, because on this one I was able to pop the gears out, or the bearings out, and put the new gears faces over the top. I'm hoping that the machine work from PCB ways is respectable, because I have to fit those same gears snugly. It doesn't have to be too tight, just snug. And that's where I can tap that stuff in, tap it back out into the aluminum. So I'm kind of hoping, and that's why I went with aluminum, because it would be a little bit more forgiving. So that's kind of where I'm going with this. We will definitely keep you updated. Chad knows. He'll tell you I'll keep you updated. Because I'm always posting something. It's either a short to kind of give you guys an update during the day on what I'm doing, what project, so on and so forth. And I've been trying to get out to fly that P-51, so I figured, throw some air past it, right? I mean, I'm sure it moved a little bit. I'll have to look at it and see. I wasn't paying attention to it. I was watching the fan. Would it be a bad idea? Hold on. I'm answering questions. Would it be a bad idea to try using an air compressor impact gun as the motor? I don't think you would have a problem with that if you consider, your air supply. If you're using this on board, I don't see that you could feasibly carry enough air unless it's a very small compressed tank has a metered flow to it. That could do it, but then you're changing the entire drive system. So you would have to pull the whole gearbox off and think, okay, how am I going to drive this fan next? Am I gonna drive it with air through some kind of impeller system, or am I gonna drive it physically with gears? And my biggest success so far was let's see if I can show you. Is it 3? Yeah, it is 3. No, it's 4. Yes. I need to grab these. This fan is a fun one. Chad knows this one well. Chad, you know which one I'm grabbing here? Let me get this pulled apart because we're not 48 volts. We're back down to 22. Let me scoot this back. All right. You know what we're doing now? I have nothing to hold this down with, so I'm doing it with my hands. You have no idea what I'm doing for you guys. Chad knows, it's not like I'm scared of it. I literally held this thing and ran it. And it sucked my shirt into it. So that was a fun day. I'm thinking this is the right direction. I may have to switch it. I had to make jumpers go from 3 to 4. Just so I could keep testing, different ESCs, different configurations, so on and so forth. This doesn't require a BEC or that ESC, as a matter of fact. So we're gonna scoot this stuff out of the way for you momentarily. All right. So the modularity of the system is kind of key. you can just pop it in. This one has a VEC on it, so I don't have to run a separate VEC for power. And this is Stubby Band version 1. Let's get some room here. Now I gotta hold the thing. Okay. Radio on. Oh boy. Oh, I better not leave that there, huh? Okay. Am I going backwards? Yep, hold on. Okay. I never can remember. Yes, I know. Quit complaining. You'll have your signal back shortly. All right. A control wire for what were you referring to on the control wire? Oh, you're talking to somebody else. I'm sorry. Well, like you were answering somebody else's question. It looks like. All right, we got people dropping in. You guys are great. I appreciate this. Now, if you missed this, you can scroll back and see it. But this one is the 600 kV direct drive. Looks like total crap because I put it through so much. But I want to put an 800 kV back on this because I put a 6 on here. But here we go. We're going to run this one up. Do I turn it towards you? I want to turn it towards you. All right. You ready? Here we go. Let it do a cool down run. That's not hard, that's not easy to hold, man. Oh, especially when you got a shoulder issue. Oh man, that actually hurt. Trying to hold that thing back. Oh. Okay. And this is all off. You gotta remember, this is all off of a 7 DC battery. When I hook up the 100C. Did I charge it? I bet I could push more. I did. Let's see if I charged it. Let's push it even more. I feel like I need to cross myself before I do this. Okay, how to hold it without dying. Okay, let's see. Here we go. Get the camera view a little bit. Am I there? No, I'm trying to watch the delay. Hold on. Instead of the camera. There we go. Okay. Don't suck the wires in, please. I do a cool down run. I'm like blowing stuff all around the shop. As you can tell, it's moving a lot of air. Oh. What? No worries, Chad. It's totally fine. Just please don't repeat that if you guys decide to build one of these, because I am going to make these files available as soon as everything's finished, especially the one with the toroidal, not toroidal, sorry. That was another idea. The one with the 4-to-1 gear, planetary gear system. Yes, I stand behind my product. That's a good one. I got to remember that one. Oh, man. Yeah, that'll dry your hair quick. I'll tell you that. But even this 600 kV has got some serious power. The 800 kV was pushing it. So what I was going to do, since the 800 kV made it scream, I mean, it was just pushing out way more thrust. I was thinking about, well, actually, I wasn't thinking about it. I've already done it. But I tried to print it out as support material. It didn't work, because I ran out of PLA. So I was like, I'll just do it out of support material. So what I did was I took 11 blades off. And then I'm going to vary the pitch on these in the program. And then we're going to run the 800 kV. But the 800 kV ran, it just got really hot to the point where after running it for a while, the magnet started to basically become dislodged. The heat was destroying whatever was holding the magnet in place. And don't get me wrong, these little turbo motors you can get on Amazon, they're really good. I just overamped the living crap out of it is what happened. So yeah, that's right. That's right, Chad. Yeah, I had this thing on the ground. I mean, I'll barely put any thrust to it. See if it'll drag itself or fly off the table. See if I can show what I'm doing here. Okay, you can see my throttle position. That's barely any throttle. And it already wants to go across the table, so I'm not going to push it too much further. It's spinning the other fan. Here, let's spin the fan. Eat my air. A little bit of a cool down run. Hold still. Woo! My wife is online. She's like, "Stop it! You're gonna hurt yourself." I don't know, guys. Should I listen to her? Oh crap! She's in the other room. I forgot. I will listen to her and not hurt myself intentionally. It will be accidental. I promise you. She loves it when I do this stuff because usually I'll use the camera that I have on the wall, and especially when I'm running something experimental with those gears, and I'll go in the house and I'll watch it on the computer to be safe, and I'll run it with the remote from inside. But I can't help myself, so I'm like standing right here running these things. And like sometimes I'll duck down behind here, behind the metal table, and I'll have the camera up here filming. I'm like, okay, I'm gonna go, and I'll get down here, and it'll just, because we saw what happened when the twin exploded. So yeah, being behind something's probably the safest bet at this point. But even with this motor here, as you can kind of tell, hold on. I don't want to accidentally hit the throttle and lose all my fingers. This one's designed with the idea that it sits at the corner of a drone. So if you imagine this is the size of the drone, you've got 4 of these motors, and they're spaced evenly apart from front to back and from port to starboard. So aft to bow, port to starboard, they'll be evenly placed. Just like any regular drone, as square as possible. And then what I'll end up doing is attach them with carbon fiber rods. These are 20 or 22 millimeter. And they'll be thick walled so that I can basically, you know, drill into them and then put the set screws in. Probably use an epoxy or some kind of buffer, something to keep it in there after I get it all set up. And then I'm going to run all of the ESCs with 2 of these, and this will push 480 on the amps, and it'll run at 48 volts. So this is the 600 kV version, 22.2 volt. That is the 190 kV version, 4-to-1, 48 volt. So there's fundamental differences between what thrust they can produce. So I am going to try this again with an 800 and an 11 blade instead of a 22, or do a completely different fan altogether to get the most thrust I can out of a 22.2 volt configuration, so that when I do build this as a drone, I know I can run it as 22. Even though the motors may be rated for 48, I can still plug them in as a 22 and run them that way. It won't be as much thrust, but I can still, it's another way to make it modular. So, and the idea behind doing this, and I'm calling it the Shrike XL, and the reason for that is because if you go to the Shrike drone playlist on my page, you can see kind of where I started with the Shrike drone until I got to the 70 millimeter V10 that I launched. This was the original design, and it didn't work because I was going analog. I had analog ESCs. I had a standard receiver. I was controlling the pitch and yaw with servos that I mounted here and at the front, and I had a pusher motor underneath. So I went back to the drawing board because the problem I was having was I wasn't sure how EDFs acted with flight controllers like the SpeedyBee F405 wing, which is what I was using. And I still use it because I like it. The only thing I had to change was this power distribution board, because APD, Advanced Power Drives, had a 500X that I can't find anymore. They don't sell it to hobbyists or enthusiasts, so I have to go LLC myself so I can go buy their products again. Which is BS, because I even emailed them. I asked them, I'm like, why are you killing literally an entire revenue stream because you want to go straight commercial? You're going to tell me you don't have the guys to keep the hobbyist, enthusiast part going without, losing money somehow? I mean, you're cutting off an entire revenue stream. Because APD, they have really good power drives, of course, and in small packages. And that would have been like the, where is that thing? The nerve system of the old Shrike drone, which I have to desolder because I use thick wire and it's just like everywhere. There it is. That's the APD, and this is an absolute mess. I've got like these nice ESCs to the iFlight EV3 V2 or something like that. But I want to put all this back together and do another Shrike, if I can recover this board, because it has some burn marks on it from my extensive knowledge of soldering. As you can see, I do the soft serve technique. But on the bright side, I still have all the parts. So I can do another strike. This time though, I'm not doing 70, I'm doing a 90. So it'll be a quad 90 millimeter. Less amps too, which means that I can get away with a smaller power distribution board. Because I was pulling a lot of amps with that other one. So, all right. So as it's 8:35 now, does anybody have any questions about anything that they're seeing in here, other than the utter confusion of my setup? If you have any questions, ask me now. Any questions? No questions? Come on now, I know you guys have questions. No, if you realistically, if you don't have any, that's fine. If you think of them later, you can always. Oh, you want to see the vector nozzle? Okay. Yeah. This has a low pressure turbine system in it, and hold on, I gotta grab a wire extension. And originally, I had set it up, but I took some bearings out, so it still functions. I took bearings out. It still has to work. Hold on. It would help if I plugged it in the right way. All right. If somebody says that what she said in their head just now, you are part of the crew. I'm telling you right now. All right, let's go with is that a 6? What 6? Yeah. All right. Battery, radio on. I wanted this to be on a potentiometer, but I only got a 6-channel receiver, and my 8th and my 9th and 10th channels on the potentiometers are doesn't want to work because I stole bearings off of it. Yep, it kind of wants to work. So okay, so it would have worked perfectly, except I did steal bearings off of it from up here and over here. So otherwise it would just open easily. But I found that wasn't as effective as it was. The low pressure turbine system has 5 separate blades in it. And, well, hold on, they look just like this. That's what's in the heart of the low pressure turbine system in here. What I did was replace that with an impeller so that I could, and then I changed the nozzle to this. So instead of having a low pressure turbine system inside, which really didn't benefit me much except for maybe alleviating a little bit of torque from the motor since it was spun on the same shaft. So as the air passed through, it would create torque relief actually on the motor, and would lighten up the load slightly. But this exit aperture is for it goes over where this goes, but in place of this is an impeller. And then this part here, because eventually I'm going to have to print the whole thing in metal. So, but especially since I'm going to adapt an afterburner to this and go from there. And the rear spindle for that is the same bearing. So you'd have 2 bearings in that configuration. That configuration has 1 for the big fan. This one has 2 because I'm using that low pressure turbine system. But yeah, I'm going with the impeller so that we can test different afterburner techniques. And since it's a high pass, if I run it not in direct contact, but if I run it close enough to, like, say, the galvanized pipe or whatever I'm using for the afterburner nozzle, the high pass fan will cool it, so it shouldn't have too much of an effect. That's going to be the test. I'm not saying it's not going to melt this, because it'll heat soak when I turn it off. But eventually all this will have to be printed in metal, and that's including the high pass fan. So the problem with that is they wanted almost $2,000 to print that out of metal. Pretty close to the same to have it CNC'd. So it's like, if I wanted to actually print all of my hard parts for this that I needed done in metal to ensure their reliability, I could afford to buy the metal printer. It's ridiculous what they charge you. Hold on, I'm reading questions. Oh yeah, there's more of these. there's several configurations of these motors. So yeah, all I have to do is print it. And I'm going to be honest with you, with running the Bamboo Lab X1 Carbon has been a lifesaver for me, because the original Shrike drone, if you go back to the playlist and you watch as I went through developing the Shrike, I had standard analog EFCs on it. It was printed in white, and that came off of the Ender 3, believe it or not. That was before I even got the Bamboo Lab X1 Carbon. So the first Shrike was white. The last 2 that I did, one had a malfunction because of an iNav configuration error, and when I tried to land, one of the signal wires came off of the receiver, so it automatically went into a loiter landing mode, but it was in a loiter plane landing mode. So it went up and did a complete circle around my house. I couldn't see it from behind the house, and then it came back around and went right through the tree. So that one I kind of put on the shelf and did version 10, which was the FDE and brown colored one that I flew at the park. I eventually wrecked that one because I was messing around with angle modes and things like that, and I hadn't had a lot of experience with iNav. So what ended up happening was I'm flying it, and then I flipped a switch because I was trying to take it out of angle mode and then tilt forward for forward flight so I could test airfoils that I'd put on it. And it just wigged out. I totally messed that one up. So I'm gonna need some practice with the iNav. Show mini. Oh, you're talking about the turbojet. I got you. Oh. This is a special one. This one runs off of a Predator EDF motor. I forget the specs on it. And I have to reprint the cores, but I have the core files already. And this one had, I called it the terror pineapple at one point because there were so many blades coming off of it. But this is also going to have a high pressure impeller. So we're going to pull in, compress, and then super compress again. So you're going to have compressed air getting compressed before it goes out the exit nozzle, which is basically, all these nozzles are interchangeable, so it kind of fits like that. And it was very, very tedious to print this with the stators in place on this thing on both sides of the model. I had to make sure that the stators would fit over the blades once I got them completed, and then still go through the bearing housings. And I used this carbon fiber rod to keep all the sections nice and straight. And then the motor mount that I built goes on and bolts onto the front here, and then that will hold the Predator, because it's a big. I think it's the same one that they put on the Scorpion, the 90mm Scorpion. It's a robust EDF engine, and that'll be a direct drive, and it will be from the front. The reason for that is because you're not getting a motor inside here. It's not going to happen because you've got too many blades. You got your first stage, your compressor stage, your low pressure turbine system, which is now an impeller system, and your exit nozzle. So there's really no room except for the front to drive it from, but it gives you an opportunity to duct everything in. So I try to design the mounts with as little interference to airflow as possible, while still giving me the stability I need. Because remember, we're dealing with 3D prints, so you have to be very, very careful how thin you make this, because if your drive motor is sitting on something really thin because you're afraid of blocking air, it can be disastrous. So a mini Neo. What's a mini Neo? I'm not ashamed to ask. I don't know everything. Well, I do. I just have a lot of it written down. That's always my excuse. Man, do you know everything? I know everything, but a lot of it's written down so I can leave some space in the brain. I don't know what the Neo is. We'll get back to that one. Tell me what the mini Neo is, Loy Leg. What are we looking at here? Is there something else? See, now that he's mentioned that, I'm going to build something else. So, yeah, that's the turbine. And there's also, that's in the, I think it's the turbojet playlist. Or turbofan playlist. I can't remember. I did a few runs with that. And I used the old 70mm, like, Dobofo motors from Amazon that I got in the original 70mm Shrike motors. And they ran for a little bit, but I smoked them. I smoked them because they were just not low enough kV. The Predator has a low enough kV, and I believe it's 48 volts. And that'll give me the power I need to make this feasible. Because the Javelin, which is another playlist you should check out, I originally did with 70mm EDFs. And the Javelin is a VTOL aircraft. And it's basically a tail sitter. But it doesn't have landing gear, so it takes off vertically and lands vertically. What it does is transition into forward flight, and then works just like any other jet, except it's got basically two rudders, one on the top, one on the bottom. It's Elevon controlled, so I didn't need elevators in the back. So I basically built the Elevons into the main wing. And then I have the rudders, which I thickened up a little bit at the rear to be part of the landing gear. So landing vertically, taking off vertically was a matter of going up, moving forward with the drone into a forward position, hitting the switch to tilt it to forward flight after I've achieved a good enough speed. And then when I come back in, you come back in plane mode at a high alpha, and then flip it back into drone mode, and then land again. So you can see on the Javelin playlist where I was going with that. Some of these projects I did have to put on the back burner. Yeah, it's a money thing for me. What can I say? I'm on fixed income, vet bennies, family of 5. I'm doing what I can because I love the hobby. I love to create things. I love to make things. And, the printer, the only reason why I got that is because my brother got a loan for it. Because I never used my credit because I was in the military. So I never bothered. That's all I ever knew was military. But this is what I want to do now since I'm home and and you know, I'm on the vet benefits, and doing what I can to survive. But the chicken mafia keeps raising the prices on the eggs, so I don't know what's going on there. They keep saying, you know, bird flu, but you know, I don't know. It sounds a little suspicious to me. I think somebody's price gouging. What do you think? Python 32 S3 instead of Arduino. You guys are having a conversation all by yourselves. What are you talking about, man? Get me in on the conversation. Yeah, eggs are horrible. I mean, they're not horrible. The price is horrible. Yeah, I mean, but other than that, I'm still getting things done. So I'm prototyping with, you know, kind of cheaper PLAs and things like that off of Amazon. But to be honest, they're all the same. Not all the same formulation, but realistically, it comes down to quality control. It's pretty much the same in the sense that it's you know, the same chemical composition. But some people process it differently, or there's different quality controls, that kind of thing. I personally like working with the matte PLAs because they don't have any layer lines out of the X1 carbon. On the X1 carbon, you won't see any layer lines on matte PLA or PETG carbon fiber. Literally no layer lines. I can't see any of them. And that's at standard print. That's like 0.20 millimeters of layer height. PETG, that's it. Sorry, a bearing came out. This is just lay down right there. Okay. This is standard PETG from Creality. It's not bad. You know, I like to prototype with these until I get things, you know, where I want it, and then I'll go for a filament that's more expensive, or a higher quality filament, or maybe even just go PLA plus. It really just depends on the application, because you don't want something too brittle. You want something that can flex a little bit, but in some cases you don't want any flex, and in some parts you do want flex. So it's sort of a toss-up on the material side. You kind of have to decide what you want to do. Now the PETG translucent, the clear translucent PETG on the big fan in the back, that seems to be the most flexible for this situation. And I say that because it's given me really good results. I can take those blades and I can twist them almost 180. And they'll go right back to where they were. And that's with full infill. That's full infill. So the PETG translucent from either Overture or Bamboo Labs is like the best. If you guys know of another clear PETG that's better than that, let me know. Because I could use it. So get chickens, no dogs. I've got 2 huskies. So they would probably play with the chickens until they're no longer living. Otherwise, it would be a good idea. I'd do one of those rolling pins or something. But I think they would stress out the chickens, my dogs, and then they wouldn't lay any eggs anyway. But other than that, that's what I have to show you this evening. This is my collection. I'm still working on a lot of it. When the Metal Gears get here, though, be ready for that. So, I mean, I'm thinking what? Man, that really tore those gears up. What do you think? Tell me what you think. You want a live when I do the Metal Gears? Or do we go with, do I just film it and then show you later? What do you think will be more productive? What's gonna What's gonna grab the most attention? You guys, do you want to see this live when I do the metal gears? Or are you cool with just a video? Yes, I have to chain this motor down. Because if I don't chain it down, it will take off, even at half throttle. So y'all want live? Okay. When I get the metal gears, we'll go live. I'll make sure you guys have a short and some ample time, and I'll try to schedule it. Because when I do these vertical lives or whatever on my phone, I think you can schedule them for later on. I believe so. Just like any other video or Premiere. So that's what we'll do. Oh yeah, in advance. Yeah, well, what I'll do is I'll do a short, and I'll schedule the video for like a day or two out. Once the metal gears get here, and then we'll go through the live. I'm gonna look at the metal gears, make sure everything meshes up well. But if you want, I'll assemble everything just like I did here live, and then we'll do it again. We'll do another live, and we'll assemble it all together, just like I did this time. And we'll spin it up. Unless you don't want to waste time watching me try to spin that up, or try to put everything together. And if you don't want to watch that, then, you know, I'll just put it together and spin it up. So it's entirely up to the audience. Okay, so that's the plan. We are looking at a few days for the metal gears because they said it would take, I think, 7 to 14 days or something like that. I don't know if anybody else has used PCB ways to have anything printed, but that's where I'm going with. So I don't know if their estimates of 7 to 14 days is accurate, or that's just they give themselves time so they can get the stuff done. So when they get here, they get here. And then the entire ring gear and everything is all done in aluminum. So even if I strip out, I'm telling you right now, if I get a sun gear done in aluminum and it ends up looking like this, that means there's some serious torque going on there. A lot of torque. And I originally wanted to get these done in tool steel, but I need to see how they mesh up well with 3D metal printing first, because they're not being CNC'd, they're being printed. And I need to make sure that they dimensionally come out the way I need them before I go with the tool steel investment. Because then I got to change up a few things. I've got to enclose that gearbox. I've got to add the bearing grease in there to make sure everything, goes smoothly. But we're gonna break that. We're gonna break that RPM barrier that I keep hitting with these nylon gears. So the quality is pretty good on PCBWay. Oil egg, that's good information. It makes me feel better. Especially since it takes a considerable amount for me to actually get stuff like that done. I know it doesn't seem like a lot, it was like $133, but to me that's a lot. It might not be a lot to other people, but it is to me. If you feel like, nobody has to do any of this. If you ever feel like I want to help this guy out to get the parts, because I don't spend it on me, I spend it on the parts. I have a Buy Me a Coffee website, or a link on my page for that. I have a Patreon where you can join up. So if you're interested in doing that to support me, that would be great. You don't have to. I'm not ever obligating anyone for it. I have the Shrike STL files. They're up there with the parts and components list on Patreon. I do have those up for $3 because I did take the time to design it. So I figured that would be enough. So $3. And that's only if you want to build it, because you got a lot of components you have to buy to get with it. So, and then you'll see it in the list. But if you do end up helping, you'll get mentions. I mean, I'm not even monetized yet, which is what I'm going for, really, so I can afford to keep doing this. I think I'm only at 1,500 watch hours, and they want you to have like 3,000 within 365 days or something like that. But they sent me an achievement saying you reached 4,000 watch hours, and I'm like, oh, but it's not within the 365 days. Throw me a bone here. I mean, I think I monetized the channel 10 years ago, and it certainly didn't take as much as it's taking now. But you know, the more you share this, the more you tell people about it, the more it gets out there, the more it helps, I guess, the algorithm to push the videos, which helps me out. And eventually, this can perpetuate itself. The money I get goes into this, and then you know, I pay down some of my you know, credit, and I can get more stuff and build bigger stuff. Because I mean, I'm going to tell you right now, my goal is to build these big enough to where I can make a quad out of them. So right now, as it sits, if I have 4 of those motors going on the drone, and you're 200 pounds or under, you can ride it. But for me, obviously, I wouldn't ask anybody to do that. I know Chad would do it in an instant. So would Spider. Spider would be like, "Oh, I'll do it. I'll get on it." Would there be anybody else in the chat right now who would ride that drone? I won't go up very high. Maybe 10, 15 feet. Anything else, I'll put a parachute on you. Come on, how many yeses am I going to get in the chat? How many yeses? Who's going to ride the Shrike XL? Who's under 2? It ain't me, because I'm 6'4" and 300. So I'm not doing it. $20, I'll do it. I had to save that 20 to dispose of the remains if something happened. I couldn't pay. I guess I had to pay in advance. Okay. Anyway, the point is, that was a joke, by the way. You'll fight. You're gonna fight him for it, Chad? It's like, oh, I'm getting on it first. No, I'm not kidding. I'm not kidding. Eventually, it's gonna be CNC parts, CNC fan, completely reliable system that is bigger, and I'll have the TIG welder in here, and I'll be doing a quad frame. I'm not joking. Hydrogen fuel cell pack from a Toyota Maya. You know, I'll have to see if they'll sell me the hydrogen fuel cell separately. Otherwise, I gotta go buy a car, which I won't do. I'll probably just borrow one. I'll just borrow somebody's Maya. I think it's the Maya or the Mariah or something like that. So it runs off of a hydrogen fuel cell. Because I don't mind the idea of, you know, riding a quad with all those batteries on it. And it probably would, you know, take very many. But there's also that concern that people have, do I want to ride this thing with hydrogen on it? So I think the first version of the quad will be built and then flown remotely, obviously, before I get on the thing, because my wife's not going to let me get on the thing. So, but I'm going to get on it anyway. I'll be like, I fell on it on accident and hit the throttle. And then I took off. So, yeah. All right. Well, to everyone who did join in and watch the live, I appreciate it. Let's do this really quickly before I end it. The stream, that is. Where is that thing? Okay. I'm going to pop that off. We're going to take a look at those gears. All right. So normally I had screws that went through here and held this in place. Because I used it so many times and had to pry it off, I just kind of go like that, like this, and just pop her free using the hot glue, you know, to hold everything. Well, that one held on tight. I don't think I'm going to get this one because it's glued down to the table. As you can see, I try to reuse as many parts as I can. Okay, so there's the motor. That mount's about had it. It's definitely working for testing. I'll be printing a new one of these for the metal, for sure. All right, let's pull that out of there. Are we focused in on there? I want to make sure we're focused so you guys can see this. Okay, lots of interflon. And where's my ring? There's the sun gear stuck on the end of the shaft, just like I figured it would be. Hold on 1 second. Getting this grease all over my hand. So it doesn't matter what lubrication I use for this. It's literally going to die as soon as it hits a certain RPM level. There you go. Just as I anticipated. Sun gear gone. That took the brunt of the damage. Not so much damage on the planetaries, but enough to where, you know, we did run it afterwards when it was stripped and kind of flatten out those teeth, but that was expected. Ring gear, other than being covered in sun gear teeth and lubrication, came out pretty good. The ring gear doesn't typically take too much damage at all, really. It actually does really well. It resists a lot of the torque on the ring gear. So I'm trying to brush this out for you so I can show you. So there's like teeth everywhere. Okay, so I'll get most of that out of there. And you can see that the ring gear actually still has a good portion of, you know, pretty much all of its teeth. They're a little bit sharper up here because I didn't use that stack. But if you look, you can see that there's not too much damage there. A little bit of wear, but not too much on the ring gear. Planetaries, definitely a little bit of damage on the outside from running it after I stripped it. And of course, our lovely sun gear, which is basically completely flat and just mushroomed out. So that's one of the reasons why we're going with metal. Because nylon 6 was basically the hardest material that I've printed so far. And it couldn't handle the torque of a 4-to-1 gear ratio. So definitely going with aluminum next. So as you can see, after taking that out, the fan still turns perfectly like it's supposed to. Everything still looks good. The box is still mounted. It's literally just plug and play at this point. I'm going to print another one of these and then kind of make sure that it's dimensionally accurate to the point where it slides in and out easily. I can use the bolt holes to secure it rather than glue. But I tend to rush things sometimes. It's a habit I have to break, but I want to keep bringing you guys content. So that's one of the main reasons why I keep doing it. Why I keep rushing stuff. So that being said, I hope you enjoyed everything that you saw here today. Share with your friends. Pass me around. That sounds bad. Pass the channel around. Yeah. Yeah, that's me embarrassing myself on social media for the whole world to see. Sorry, 11 of you. Other than that, everything worked out well. It turned out really good. It did exactly what I expected it to do, which was really good in confirming my suspicions. It didn't matter what material I used. The nylon 6 did hold up more, but once it hit that certain RPM band, it just basically strips that sun gear out. It just tears it to pieces. So I don't think any amount of 3D printed gear other than metal 3D printing or CNCing the parts is going to hold up in that planetary system. So that's what we're doing. So, be waiting for that. And I hope to see you all here again for it. I hope you guys like how the shop's coming around, how it's looking. I haven't got to use this metal detector yet. There's the Cuddy Black I'm doing for Star Citizen. That's one of the other reasons why I'm building a high-pass fan. So without the cowling and that small cross-section of ductwork, I can use it for, basically gravity-defying stuff, basically mitigate the weight of the aircraft and then have drone motors on the insides, on the back and the front. And, of course, the nacelles on the back of the Cuddy are going to rotate, so on and so forth. But that's another project. I got a lot of projects. Well, thank you all for being here. I appreciate it. And I will see you all again soon. And I appreciate all your support. I appreciate everyone who has subscribed, everyone who shared, everyone who's bought me a coffee on the page or joined Patreon. It isn't that many, but it's enough to keep my hopes up. So I hope you all have a wonderful evening. And I can't wait to see you all again. Until next time, this is DPC, and we're out.